Today, I'm going to be talking about the key points in finishing production. And I'm going to be talking from the perspective of technical service. So I'm going to be talking in a lot of detail. So I'm going to move this out of the way because I can't see. So finishing production, the key points for finishing production are the same whether you're using facilities in the United States or facilities in Brazil or Guatemala. So these are the areas that we're going to cover today. We're going to talk about the three basics, briefly talking about the daily technician routine. We're going to talk about feed from a feeder perspective, stocking rates, water, and environment. Okay, so three basics are the same everywhere, and that's feed, water, and a clean, dry environment. And we're going to talk a little about each in today's presentation. Okay, so this first page is a little busy, but this is our recommended nursery and finishing daily schedule for the technician. And yours may be different, that's okay. But the key point about what the technician looks for every day should be the same. That they're evaluating the environment and that they make changes to the environment if it's not correct, that they check the waters, every one of them, and then checking the feeder adjustment to make sure that every pen has feed. So one of the major goals for the nursery finishing technician is to look at every pig every day. And when we're looking at the pig, we're evaluating the pig for its health, whether it can walk normally, and then recognizing that, responding to that pig's needs. So I use the counting method in order to be able to look at every individual pig. So you go to a pen and then you individually count each pig, and that forces you to look at each individual pig. I'm going to move on to talking about feed and specifically feeder adjustment. So feed cost is typically 60 to 70% of an operation's costs. So it's an area that needs to be managed very closely because the amount of money that's involved. Okay, so this is the results of a study done by Tim Schell of University of Georgia, Eric Van Houten of North Carolina State University, and Alan Harper of Virginia Tech, where they estimated what the feed cost is based on feed waste. So there are very few studies on feed waste. So most researchers use an estimate of between 2 to 20% of feed waste on swine farms. So the table on the left illustrates the cost of feed waste on a per pig basis. So what the authors looked at was the percentage of waste over the growing period of a normal finishing period, and in this case about 91 kilograms of gain. So looking at the chart, in the first column is the percentage of feed waste. The second column is it's feed needed for 200 pounds of gain, but in your case it would be feed gain for 91 kilograms of gain. Okay, and then the third column is the cost of feed per pig in dollars. And then the fourth column is the waste cost per pig in dollars. So, for example, in a very efficient unit, if they only had 2% feed waste, the feed cost would be $33.66 for 91 kilograms of gain. And the waste cost per pig would be 66 cents. In a less efficient unit, if they had 8% waste, the cost per pig for 91 kilograms of gain would be $35.64. And the waste cost for 8% feed loss would be $2.64 per pig. So it's easy to see, for example, head finishing facility where $2.64 would be very expensive for the producer. Okay, so these pictures illustrate recommended feeder adjustment based on age. So the upper left picture illustrates the feeder adjustment post-weaning. And you see in that picture, there is more feed on the bottom of the pan of the feeder than there is in the other pictures. And this is because the pigs are small and it makes it easier for them to access feed. Because of their size, they cannot push the feeder as hard to get feed to drop. So we want the adjustment to be a little higher to allow easier feed flow. The upper right corner picture is an example of the feeder adjustment 2 to 3 weeks after the initial placement of the pigs. And you can see that there is not as much feed in the bottom of the pan, but it's still there's still a fair amount of feed coming through the gap. So it's easier for the pigs to eat, but they're larger and they can work the feeder a little better at that age. And then the final photo on the bottom would be the adjustment for finishing size pigs. And these would be larger pigs that can push on the feeders to get the feed to drop. And the obvious reason why we want to tighten the feeders down is to reduce feed waste. And so the older that they are, they will waste more feed if the feeder adjustment is not proper. Okay, so how do we maintain the feeders in the proper feeder position, get the gaps correctly? So one of the recommendations that I like to give is using these feeder adjustment cards. So they are actually photos of properly adjusted feeders that are kept inside each building, and that the technician can look while he is adjusting the feeders, and it helps him understand what the feeders should look like. And in fact, there's a link on the bottom of this slide where you can actually order these feeder adjustment cards from Kansas State University. This is an example of a properly adjusted rotary feeder. This is a properly adjusted wet-dry feeder or shelf feeder. Okay, the other issue that we need to look at in terms of maximizing feed intake is the amount of feeder space that's required for each pig. So this is work done by Dr. Mike Brum while he was at the University of Nebraska, where he has estimated the required space based on the size of the pig feeder space. So it's pretty obvious why this is important. So if you have a 4-hole feeder and it's a small 4-hole feeder, when the pigs get larger, then fewer pigs could actually eat from them, thus reducing your feed intake. So in the table on the left, the first column is pig weight in kilos. And then the second column is the shoulder width in centimeters. And then the third column is the feeder space width in centimeters that's required for that size of pig. Okay, we're going to talk about stocking rates. Okay, so again, this is more work from Dr. Mike Brum on stocking density. And this is called predicted adequacy of space allocation for fully slatted facilities. Okay, so the first column is the weight in kilos, and then the second column is adequate meters squared per pig. And then if the density is 5% more dense, the effect if you reduce the area that the pigs live in, that affects average daily gain. So for a 5% reduction in space, so if you go from 0.27 meters squared to 0.23 meters squared, you'll see a 5% reduction in average daily gain. And so there's this table shows that at each weight that the meters squared, when it's 5% below the optimum, it affects average daily gain. So the question that I get a lot is, what does the density do to feed conversion? The impact, today there is no definitive research showing the effect of change of feed conversion with the change in density. In some studies, it shows that it does change, and some it doesn't. Okay, water. So water is the most important essential nutrient. It must be of good quality and be readily available. So water is involved in metabolism, nutrient transport, and temperature regulation. Okay, so we're going to go through some steps on how to optimize water intake. So first is checking the flow rates. So the flow rates determine the time that's spent at the nipple waterer, water intake, and water wastage. So here are the recommended guidelines for minimum flow rates at the various stages of production. So for the nursery, the minimum flow is 250 to 500 mLs per minute. And for finishing, it's the minimum is 1 liter per minute. And again, just as a reminder, because of the importance of water to production, it's important that the technicians check the waterer every day for proper flow. Okay, number 2, mounting the water nipples correctly reduces water waste. So there's generally 2 different types of angles that the nipples are mounted. One is where it's straight, and that should be mounted about shoulder height for the pig. So the pig can aim its mouth straight. So for nipples that are mounted downward at a 45-degree angle, the nipple should be about 5 centimeters above the back of the pig so that the head is tilted up. And mounting the nipple waters lower will increase water wastage because the pig can't lock its bottom jaw on the bottom of the nipple correctly. So it presses down on the nipple, and a lot of the water dribbles out of the pig's mouth. So this is a picture of nipple water that's mounted correctly for the age of the pig. So this is for a nipple that's at a 45-degree angle. You can see that that the nipple is mounted at the correct height, and that the pig is able to lift its head up and get its mouth totally around the nipple to consume the optimal amount of water. Okay, so now here are the recommendations for the height of nipple placement. So on the left would be the pig size in kilograms, and then on the right would be the height of the water nipple placement. Okay, now we're going to talk about drinker comparison and water wastage. So when ranking these different types of water delivery systems, the nipple water wastes the most water. The swinging drinker is more efficient than the nipple water, but less efficient than the bowl water. Correct. So the bowl drinker is has the least water waste of the three. So this is a study done at the University of Nebraska where they compared nipple waters to cup waters in terms of water wastage. And this was a grow finish study. Finishing study, right? And you can see the results where the nipple waters used 5.7 liters per pig per day versus the cup waters that used 3.8 liters per pig per day. So there was a 2 liter per pig per day difference in the type of waters used. And it's easy to calculate, in 1,000 head building on a per day basis, 1,000 pigs times 2 liters is a significant amount of water wasted on a daily basis. This is another study from the University of Nebraska looking at water waste and cost, specifically medication cost, where they treated the pigs for 5 days using a water medication of sulfodimethoxine. So the results showed that this was a trial using a bowl water versus swing nipples. And so the results in terms of the amount of water used per pig per day for the swing water was 7.4 liters. And then for the bowl waters, they only used 3.7 liters per pig per day. So not only did the swing waters use more water, but when you looked at medication cost per pig, it was twice as expensive. It was 16 cents per pig for the medication for the swing water. Okay, we're continuing on with optimizing water intake. Number 3, some of the factors that contribute to increased water intake. So if you note on the bottom, an increase in temperature from 15.6 degrees Celsius to 30 degrees Celsius will cause pigs to drink more than 50% more water. And then B is hunger. When they're hungry, they'll drink more. And then boredom. And boredom, what I mean by boredom is that they'll just sit there and play with them, especially when it's warm. Okay. Factors that depress water intake. So cold stress. So when they're cold, they do not want to drink. Warm water, they prefer cool water. A high level of salinity in the water. So I've actually seen an issue with high salinity in water in a farm that was very close to the ocean. And when they drilled their well, they actually hit ocean water. And during the startup of the farm, the pigs, the producers could not figure out why the pigs would not eat. And it wasn't until that they did water testing that they learned that they had ocean water and not fresh water. Okay, so what time of day do animals drink most? Research has shown. So for nursery animals, typically they drink before 8:30 in the morning to about 5 in the afternoon. For finishing animals, generally between 5 in the morning until 11 in the morning, and between 3 p.m. and 9 p.m. Okay, so this is just a quick checklist to optimize water intake. adjust water nipple height, check flow rates, recognize that temperature impacts the water requirements and the factors that depress water intake. Okay, I'm going to talk about a little bit about how we can use water meters to predict oncoming health problems. So this is information from the University of Nebraska, and they use wet dry feeders in this trial. And so this is data taken from 2 different buildings, and there were a total of 6 groups that they looked at. And what you can see here, so on the left side of the graph is the volume of water that the pigs drank. And then on the bottom is the number of days post-weaning of the age of the pig. And what this study shows is how consistent each of these groups are in terms of water intake based on age. So this is another study where they were looking at cup waters and the water intake for cup waters. And then again, on the left is water intake. And then the bottom is days post-weaning. And we get a similar shape in the graph of water intake as the pigs get older. Okay, so looking at water and feed as predictors of illness. So this is a program from a company called DICAM USA. And University of Nebraska did a trial with them. So the blue line above shows water intake on an hourly basis. And then on the bottom in green is feed intake on an hourly basis. And the red line for both graphs indicates the average intake. So on top, the red line indicates the average daily water intake, and the red line on the bottom shows the average daily feed intake. And as you can see where the line for influenza is, you can see where the red line drops. And you can also see where the feed intake drops at the same time. And in this case, they monitored the water intake, and then approximately a day after they identified the drop, or a day and a half after the drop, they began water medication to I'm sorry, Felipe. So what this example shows is that we know normally as the pigs get older that water intake should be going up. But when water intake goes down, that's a solid signal that something is wrong in the building. So we can do this both by measuring water and feed intake, but it's easier to monitor water intake because we can use a meter to evaluate water intake versus feed intake. Right, and it's much more difficult to measure daily feed intake because that requires specialized feeders. Now, the farms don't necessarily need to have a program to measure water intake. This is a record designed by the University of Nebraska to measure daily water intake. So as an example, on this next page, you can see here where the technician has recorded water intake and has in his daily or hourly measurements shows a significant drop in water intake. Okay, environment. Okay, a pig in confinement facilities is a captive of the environment that is provided. So the pig has no control of its environment and is totally dependent on the technicians that work in those buildings to provide the best environment. It is extremely important to observe the pigs regularly, as their actions will indicate their comfort. Okay, so what is critical temperature? It's the temperature at which a pig stops utilizing feed energy for growth and maintenance and begins using it for the metabolic processes to keep warm or cool. Okay, so lower critical temperature is where the pig is cold and will eat more feed in an effort to heat itself. So the production result is an increase in feed consumption and a decrease in gain. So here's another study done by Stephen Hoff from Iowa State University looking at the effect of temperature on feed intake. Right, so he looked at the effect of air temperature on feed intake on 40-pound pigs. So the first column shows the degrees in Celsius below the optimum temperature. The second column is the extra feed in kilos per pig day. The third column shows the additional number of kilos per day in a 1,000 head barn. And then the fourth column is the added feed cost per dollar per day per barn. Right. So for example, looking at the first column where it's 2 degrees below the optimum temperature, the extra feed in kilos consumed per day per pig is 0.034. And so for the total building for that one day, those pigs consumed an additional 34 kilograms. And that cost was an additional $5.30 per day. And obviously, if it's colder than 2 degrees below optimum, they're going to consume more feed and it'll be more expensive. Right. And so you can also calculate perhaps in the winter time, if the pigs for 30 days, 40 days, you can calculate how much losses that the producer is making when he cannot maintain the proper building temperature. Okay, the upper critical temperature is when a pig is hot. It will consume less feed in an effort to minimize the heat production from food digestion. Right, and the production result is a decrease in feed intake and a decrease in gain. So how do we measure critical temperature? Is through a technique that we call effective environmental temperature, EET. So this is not necessarily looking at a thermometer and saying this is the proper temperature for the pig. It's actually looking at the pigs and observing them and their reactions to the environment. So for example, in the chart to the right, in the middle, you can see a chicken that is in its optimum thermal neutral zone. It's very comfortable. And I can tell that even without looking at a thermometer. And then to the right, you can see where the chicken is hot. So visually, we see that. So in pigs, we'll see an increased respiration rate. We'll see the pigs spread apart. There are many signs that show that the pigs are hot. And then to the left is the same, where we can observe that in this case, the picture of the chicken looks cold. And so in pigs, we know very well that pigs pile up. They get very close together when they're cold. And we can see that even though we don't necessarily need to know what the temperature is. Okay, this is an example of a thermal neutral zone. So on the left is the temperature in Celsius. On the bottom is the size of the pig in kilos. And you can see from this graph that based on the pig's age, its temperature requirements are very different. But the basic rules for critical temperature are the same for all ages of pigs. So the pig is comfortable between the upper critical temperature and the lower critical temperature. So that whole zone that is filled in is the area where the pig is comfortable. So anytime that the pig is, the temperature is above the critical temperature is when the pig is, in this case, heat stressed, and feed intake will drop and growth will drop. And the same for the lower critical temperature. When the pig is in an environment that's below it, the lower critical temperature, it will increase feed intake and reduce gain. Okay, there are 4 ways that pigs lose heat. So there's convection, where heat loss from the pig takes place due to air movement over the pig. Then there's radiation, and that's heat loss to the surfaces of the building. There's evaporation, so that's heat loss from normal respiration and moistening of the skin. And then there's conduction, and that's heat loss from the body when it comes in direct contact with a solid material such as the floor. Okay, in a 24-hour period, typically 40% of the pig's heat loss is due to convection. Radiation 30%, evaporation 17%, and conduction 13%. Okay, and so on the right is a picture of the various ways these 4 types of heat loss can occur. So the number 1 way that pigs lose heat is convection. So that's a very important part of the ventilation system in hot climates. Right, so this building has 2 different types of convection cooling. One is tunnel, where the fan is on the right and on the left, and the evaporative cool pad is on the right. So you can see in the picture where the air enters through the evaporative pad, that red area at the back of the arrow indicates heat, and as it goes through the evaporative pad, it's cooled. And then there is an example of the fogger mister just to the left, where it also shows where the end of the arrow is red, and as the air moves through the fogging system, the air is cooled and the arrow turns blue. And then to the left of that is the sprinkler system, where the droplets hit the back of the pig. Right, and then the arrow showing evaporation. As the water dries, the water pulls the heat from the pig's body and disperses into the air. And then to the left, where the pig is laying down on the floor, is an example of conduction, where there's a tremendous amount of the pig's body that is in contact with the floor. So typically the floor temperature is cooler than the pig, so the pig will be transferring heat energy to the floor. And then finally, an example of radiation is the sun, and the sun radiates heat onto the building. And the yellow arrows that are coming off the roof show the radiation from the sun into the building. Okay. So the ventilation summary. So high temperature reduces feed intake, and it leads to decreased body weight gain, inconsistent market weights, decreased feed efficiency, higher fat deposits, and reduced carcass quality. So as an example showing what heat does to the potential growth rate of the pig, I'd like to describe this table. 1 would be typically winter months. Quarter 2 would be typically spring, and then quarter 3 would be summer. And it's very easy to see the change in growth rate from the cooler winter months to the summer months and how it impacts growth rate. So how do we manipulate the pig's environment to improve their comfort level and increase their feed intake? So we look at the facilities, the flooring, insulation, the ventilation system, and in particular, making sure that all parts of the ventilation system are set and operating properly. And then animal observation, the use of EET. So the recommended effective environmental temperature based on different size and age of pigs. So it's obvious that the larger pigs can handle cooler temperatures, and the younger pigs desire warmer temperature pigs. Okay, so this table is where we're looking at factors that change the EET, the effective environmental temperature. So there are 4 sections. There's airspeed, floor type, and evaporative cooling. So how to read this is for airspeed, that would be where the fans are moving air through the room. So if the airspeed is 0.46 meters per second, that changes the temperature the pigs feel by minus 7.2 degrees Celsius. So they feel 7.2 degrees cooler, but there's no change in the actual room temperature. So another example would be a floor type of dry concrete. When the pig lays on it, the pig feels 5 degrees Celsius cooler, but yet the temperature of the room does not change. It's still exactly the same as it is. And the final example I'm going to share here is the Fogger Mister system, where it makes the pig feel 3 degrees cooler. So I want to talk briefly about the heat index. The value heat index tells you how hot it feels outside given the temperature and relative humidity. So a higher relative humidity means that there is more moisture in the air, and more moisture in the air slows the pigs and our ability to cool. So this is a relative humidity chart. So on the left is the relative humidity. So in a typical summer day where I live, the temperature would be 30 degrees with 65% humidity. When we look at the relative heat index for a 30-degree day with 65% humidity, the temperature that we and the pigs actually feel is 40 degrees. So when we look at the thermometer, it's saying 30, but what we really feel, with this example of effective environmental temperature, what we really feel is 40 degrees. To show you the effect of humidity on the growth rate of the pig, this was done in Vietnam. This study was done on 60 kilogram pigs and looked at 3 different humidity levels. So in this graph, you see the feed intake on the left, then the room temperature is on the bottom of the graph. So even in optimum temperatures, the room that had the 50% humidity always performed better than the 2 other groups, the 65 and 80% humidity. And then as the temperature increased to somewhere around 25 degrees centigrade, all groups of pigs' rate of growth dropped. But what's interesting is that the 65 and 80% humidity groups were basically the same, but they dropped more quickly. The rate of gain dropped more quickly than the rate of gain of the groups that were raised in 50% humidity. Okay, so we're looking at the math. So we're going to calculate the finishing pig's effective environmental temperature. So if the air temperature at pig level, what it says on the thermometer is 32 degrees centigrade. Then we look at our heat index chart, and we have 65% humidity, and the pigs are actually feeling 40 degrees Celsius. So now we're going to look at our building and our ventilation system to see what we can do to reduce, to improve what the pigs feel in terms of temperature. So if we have fans where we have the airspeed of 0.46 meters per second, we will reduce the temperature that the pigs feel by 7.2 degrees. And the building has a medium insulation. Good. That'll help the pig feel roughly 2 degrees cooler. And if the pigs are on dry concrete, they'll feel 5 degrees cooler. And there's an evaporative cooling system. That'll also make them feel 3 degrees cooler. So we can subtract the differences the facility makes from how the pig feels with humidity of 40 degrees, and we end up with a temperature of 22.3 degrees Celsius. So the pigs feel like it's 22 degrees. The actual thermometer says 32 degrees. And then if you remember, we talked about the large finishing pigs comfort zone, and those pigs are comfortable from 15.5 to 24 degrees Celsius. And so my final point is an example of where we made a significant ventilation change in what it did for us in productivity. So we converted curtain-sided finishers that had fans to tunnel ventilated with evaporative cool pads. And what we found, this was, we compared 20 groups of our typical building to 5 groups with the tunnel and evaporative cool cells. So this was not a controlled trial. This is purely just observations, just collecting of data. So when we looked at the comparison, the improvements that we saw from the tunnel ventilated system were significant. So we saw a 0.09 kilograms per day increase, improvement in average daily gain to the same market weight, to the same age at market. We saw that the average market weight was 6.6 kilograms heavier. And then our feed conversion dropped by 0.1 kilograms. And then our mortality dropped from 2.2% to 1.3%. So the purpose of me sharing this information with you is that that ventilation can make a huge impact on the productivity of the animals in finishing, and the cost and the return to the business. Okay, very good. And that's it. Thank you so much for spending the last hour and a half or so with me.